So while I'm setting this up on ForgeRock, so for those who know, originally Norwegian company, we were founded from the ashes of Sun Microsystems. When Oracle bought Sun, there were already some parts of Sun that were open sourced, and that also included the identity and access management products. So ForgeRock, some guys in Norway, throughout the world, Spain and the UK, decided to pick it up, and they founded ForgeRock, which was 5-6 years ago. And today we've taken those products and already moved them towards the new age of one of things, Internet of Things as well. So enough about ForgeRock, let's start the talk. Maybe just a first question to the audience, something to ponder about. Things, do they need an identity? Do they have an identity? Do they have a concept of privacy maybe? Because things often work for us and things often capture information that belongs to us. So maybe things like privacy could also be very relevant for things. So ponder about that while I'm giving the talk today. So the Internet of Things, you probably heard the term quite often, a bit too often most likely. It's become quite a big buzzword and nobody really seems to really understand what it means. It's a bit similar to cloud in the early days and maybe still today. It's a bit of a magical buzzword. So what about IoT? First of all, some concepts which I just would like to briefly explain because you probably heard terms like M2M, Industry 4.0, just so you know how they map onto each other. First of all, the bottom layer M2M is often when you talk to telcos, they will talk about M2M. It's just basically machine-to-machine communication, putting chips into devices, all kinds of technologies just to allow them to communicate. That's the only thing it does. M2M is just setting up the basic connectivity layer for the Internet of Things. Now, of course, lots of these things will have a limited capacity, so the M2M solutions need to be tailored for that. But I will come back to that later on. When we move a step higher, industrial internet, often when you talk to big manufacturers, German ones, for example, they will often go to Industry 4.0. It's a broad term to indicate the new manufacturing era where we have fully automated factories, fully connected to centralized command centers, etc. Industry 4.0 is a little bit broader concept, which also includes 3D printing, augmented reality, things like that. So really a broader concept. One level above, the IoT space, and it really sits in between the lower level and the upper level in the sense that it tries to connect physical things with consumers, with users. That's really where Internet of Things, the IoT space plays. We all know the internet, which is mostly virtual, and then you have one global denominator, Internet of Things, Internet of Everything, also being coined sometimes. So I hope that clarifies. IoT, is it real? Most people often wonder about this. Yes, it's quite real, actually. This is a recent report from 2015 by IoT Analytics, based upon activity, online activity, Google, LinkedIn, Facebook, whatever, just to see the amount of activity online regarding IoT applications. Of course, wearables are one of the top applications here. It's also the sources where they get the information from, most likely wearables is number one. Smart city, smart home, industrial internet, etc. Often search for applications. Now, when we go a little bit more today, these are projects listed in Q3 2016, also by IoT Analytics. So over 500, 600 projects worldwide. And you see where they are structured. So here we see connected industry, one of the big players. As you know, outsourcing has become less and less efficient, so you now need to start updating your factories as well. This does not include connected home or wearables, if you wonder why these are missing from this slide. So if you're not convinced yet, it is true today, and I will also show you some examples. So all nice, we have all these fancy applications, all kind of things will now be able to talk to basically everything. Are there any problems on the horizon? Yes, of course. That's why I'm here today. So let's start with one example. This is in July 2015. These two guys, Chris Valasek and Charlie Miller, successfully hacked the Jeep Cherokee car wirelessly. Basically, they found a way to get into the entertainment system and from there on basically bridge the gaps in the car to also go to the control systems. They were able to kill the engine, turn on the brakes, disable the brakes, even steer when it was in reverse mode, and even track the car where it was going everywhere. So quite scary what these guys were able to do. Just for information, they did a recent one again this year, same model. This time they were not able to get in wirelessly, but if they hook up their machinery to the internal ports of the car, they are able to take over the car entirely. So, things to wonder about: if you're driving your new fancy car, who is controlling it? You or somebody else in the vicinity? Another great example of how scary IoT can be is about connected health. This guy, Jack Barnaby, used to work for McAfee, and he demonstrated in this particular example in 2012 how to hack an insulin pump. Usually these kind of devices, if you just know the serial number, you're able to get in, which is pretty weak security. But he was able to do it even without, because he found a leak in one of the APIs of the product, basically leaking the serial number, so he could basically do it remotely, just attack the device. He was able to adjust the insulin levels, but also fully disable the device. This is lethal, right? Just for information, Jack died, I think last year, under really weird circumstances. They assume that some of the industry is involved, but that's guessing. But he also was preparing a talk for Black Hat conference about hacking peacemakers, also on distance without having serial numbers available, basically killing somebody on command remotely. Pretty scary stuff. So 2 examples, some other industries, connected home. Recently, some guys from the University of Michigan did a research on the Samsung SmartThings platform. It's an IoT platform from Samsung. And they basically discovered it was possible to inject PIN codes for smart locks, to read out the PIN codes from the smart locks, and multiple of these kind of similar attacks. Typically, what they found were problems with overprivilege. So basically, when apps have a certain scope, they usually get too much privileges and are able to do much more than they originally are intended. They also found some bugs in the implementation of the OAuth protocol used. Connected industry. We know a famous attack in Germany where attackers were able to basically halfly destroy a German steel mill. Basically, often it has to do with the fact that once they get on the network, there are no real security vectors anymore to attack. And then last but not least, there's also a lot of smart farming going on where you basically give all your livestock chips so you can track them and see their status and their information. We're not sure yet if some are hacked, but maybe most likely in the future that will happen too. Now, from all these attacks, what is common? So first of all, as I said, there's a big security concern with IoT. And if you look at all these attacks, they're pretty basic. If you're familiar with web security, this is pretty basic stuff. Often, with most of these hacks, like the connected car, it's once you get on the network, it's pretty easy to get deeper in the network. So there's basically little authentication, there's little authorization involved within the network itself. Privacy concerns, especially connected health, gives a lot of privacy concerns. You're probably very interested in all the applications where doctors are able to monitor all your information, maybe a smart toilet which can analyze your daily producings. But again, we're very worried about who can see the data and who has access to the data. So that's a top concern for IoT. That's why a lot of companies are not moving into these projects. Secondly is that understanding the value of IoT is pretty difficult. because most of these setups, it's pretty unclear what value they bring for the organization, which is something to be worked on from a business level. A lack of solution knowledge, and that's also common with lack of skills. Basically, a lot of people out there are not yet familiar with the solutions, and that's pretty normal because they're still being built today. And last but not least, lack of standards and interoperability. I have a famous slide, but I don't have it in the slide deck, with over 150 protocols and standards in IoT today. And every day there are new being created, and some of them are neglected again. One of the big things with the standards is that the big players, Apple, Samsung, etc., they control much of the space, while all the other players are trying to basically agree on common standards. It's a big question if the likes of Amazon will basically jump onto these standards. So, I hope you now understand, one of all, Internet of Things is real. There is a problem with it, a security issue. So let's go a little bit deeper on how does it work, the IoT. Is there some kind of general mind map which we can use when we talk about IoT? Yes, there is. In a recent report from Gartner, they released a model. Looks pretty similar to this one. So on the left, you have the consumer, whoever's using all these products. And then you have the edge, which is the first block on the left. And that basically is everything sits in a sort of a vicinity of you. All the devices, things, sensors, whatever you have, close to you. Then you have an IoT platform, which is the middle block. Which basically allows you to interconnect to all these devices. So for example, platforms are provided by Verizon, Samsung, so a lot of telcos, a lot of manufacturers for devices, they do provide these kind of platforms. And on the right, you have the services, which are typically enterprise services, your true applications. These are integrated through APIs with these kind of platforms. So let's zoom in a little bit. You have two kinds of devices. You have simple things, which are really, really small things, limited resources, limited capabilities, and they often don't have the ability to talk at the HTTP level. So they talk something else. There are many, many different standards in that space, but two of them are sort of less emerging as big players. MQTT and CoAP are most often seen. And basically through these very basic standards, they communicate with each other and with other devices. So what's very crucial that you need the concept of a gateway to transform these lower level protocols into something HTTP, something that we like on the outside to communicate with. These are gateways. Producers of gateways are ARM, Intel, Gemalto, etc. They really specialize on producing these gateways, and often the two are also combined into one product. A lot of stuff is still happening on this market. When you go a little bit lower, you have smart things, and smart things are able to directly communicate through HTTP. So they don't need these gateways. They can directly go to a service or through a platform. So the function of the platform is basically to connect app builders with the things connected to the platform. Especially Samsung Smart Things is just like that. You have a concept called a smart app, which allows you to communicate with all the things on the platform. Of course, devices can talk to things themselves over local connections. So if you look a little bit at the M2M space, which is, like I said, where the telco plays, you see a couple big things popping up. 5G, for example, but 5G is very, very expensive and it is very heavy on resources. So it could be good for maybe the gateways, for local components, which then bridge with more simpler devices through something like Wi-Fi, Zigbee, or Bluetooth Low Energy. Also interesting is that telcos are also working on low power networks. So these are wide area networks, low power consumption, like LoRa, like Sigfox are very popular ones. Which are, for example, are ideal for smart cities, for example, where you have a lot of sensors in a wide area, not really in one located space. So have this mind map in your mind for IoT, how IoT is created. So now let's zoom into how the humans and things get access to resources. And the question I'm asking here to the audience is, are there really differences between how a human and how a thing is accessing services on the IoT space? So let's first zoom in on a general mind map on how access is acquired. So on the left, you have a client, can be your smartphone, a device, but can also be something more simpler. And in some cases, you will have a user using that device, like your smartphone, you are using it. But you also have smart things which are in your house, which you're not using all the time, but they do have a certain relationship with you, to which I will come back to. You have the lower part is a trusted provider, basically an entity who can authenticate your device or your users, and then issue certain statements about that. And on the right, you have the service, which is the business service that you are providing. The service and the trusted provider can be one, for example. There's certain implementations where they are both together, but they can also be separated, even in different domains by different providers, etc. So the first step would be that a device or a user would authenticate to a trusted provider. I will come back to that, how it can happen. And the trusted provider will then issue a statement, an identity statement or access statement, both or just one of two, which will then be used by the client to talk to the service. So the authentication step is something that happens not so frequently. It only happens once in a while to authenticate. Depends on your use case. So when you're accessing the service, you will always present the identity or access statement to get access to the service. The service can also talk to trusted provider to get more attributes about you or the device, can also validate the statements, and can also get more authorization decisions from the trusted provider. So it's a general mind map which sort of less fits most of the technologies which I have encountered so far. So let's move the first step, authentication. So if you compare to humans and things, people often think that things are quite stupid and they can only have a password embedded into the code. Well, no, basically devices can be as smart as humans and maybe even smarter than humans, right? So there are 4 categories when you look at authentication. One, you have knowledge, which are secrets or knowledge you have. But of course, they require some secure storage. You need to keep them safe. For humans, these are typically password, PIN. When you talk about dynamic knowledge is when a provider generates questions coming from databases. This comes back when I talk about assurance levels for identities, for example. Then the accessibility is a second level of authentication where you prove to the service that you have access to another channel, which can be through a front or back-end channel. Front-end channel is, for example, a one-time password through SMS or email. Back-end channel is when you basically ask a certain service, let's say Amazon, to say authenticate the user for me. And then Amazon will push out to your device and provide a pop-up where you can then say, okay, it's me. You can do a local authentication with Touch ID, for example. The big difference between humans and things in this perspective is that humans will use a UI, but things can also use the APIs. So they can also do this kind of checks. Then last but not least, properties, which for humans are most commonly looked at as biometrics, which currently is quite popular today. Why? iPhone, Samsung, they all now have these sensors available, quite cheap, so everyone can now start using them. For devices, you have similar things. For example, the chip manufacturers, ARM, Intel, etc., they're producing identity chips within the chips, within the processors, which basically allow you to get a unique identity from the chips that they produce. Now, of course, I don't agree that a chip is really the true identity of a device because you can modify it, you can change it. So it's just a part of a device. For example, also the telcos are using the same technique with the SIM cards. They really want the SIM cards to be your next identity, so they have a new business case for it. And then last but not least, behavior. So behavioral analytics can really be interesting for humans and devices. They're quite unique behavioral patterns. So when we look at PKI, which is the topic for today, we can look at the right top corner. This is public key, for example, private key, an asymmetric key setup. So for things, this is more easy because they can basically remember an asymmetric key more easily than for humans. For humans, we always need some intermediate because we can only remember a password or a PIN if you don't have too many of them. So they're more suitable for things, most definitely. Now, the industry is moving towards the bottom because the upper layer is proven to be very difficult to manage. So we have a lot of attacks these days on passwords. If you look at IoT attacks, often the passcodes are just embedded in the code. So most of the industry is moving to the lower part of the spectrum. Now I'm going to get a bit more technical when we talk about identification of humans and things. I classified 3 categories of technology for you guys today. So first of all, X509, you're all familiar with it, and things like SCEP, which basically allow you to get more easily certificates online. And then we have 2 other protocols in use, the web services world, everything SOAP related, which is centered around SAML, and then the other one, REST-based architectures centered around JOT and OpenID Connect, for example. So maybe you don't agree with me on some of these items here, and I'm happy to get your feedback on that after the presentation. So just to highlight the advantages and the drawbacks of certain technologies, as we all know, certificates X509 are quite secure, they're very secure. And they can be used at network level, which is quite unique. The other standards here are only at transport application level. When we talk about SAML, for example, it provides better privacy than, for example, certificates. Because anytime a service is asking for identity, it's basically a one-time assertion being generated, and you can select which attributes will go to the service. While with certificates, it's basically a piece of information which you then sort of less need to blank out certain things. Can maybe be done, I don't know. And then we go to REST-based architecture. So why are we moving towards the lower part of the table here? Is because these days a lot of stuff is not web-centric design. So SAML, for example, also a lot of stuff with certificates is built around web design and about stateful architectures. In REST architectures, most things are stateless. And what is the difference with stateless and stateful? Stateless means that every time you go to a service, it's like a new request. So the session is not with the server, the session is with you, and you present certain stuff to the server, like an encrypted JOT token, for example, that then a server unpacks and looks at and then says, okay, this is your state, and I'm continuing from that. So it's a quite different mindset. That's also why SAML, for example, right now is also losing its popularity in the scene. One big drawback with these modern architectures is the security is pretty low to medium level. Because it needs to be high speed, it needs to be agile, developer friendly, etc. Security levels for these kind of technologies are pretty low. There are a lot of stuff being added to the standards and optional pieces which you can implement if you want to have more security with these standards. So this is about identification. So basically having a piece of your identity wrapped into a statement which you can present to a service. One important thing I just want to note here is assurance levels. I've been involved with NIST in the US and also with the UK Verify scheme in the UK and also with IDAS in Europe. They define a lot of identity assurance levels, right? So the top one is strong authentication, identity binding, which means proving online that you are who you say you are. And level 4 in most of these schemes will require strong cryptography and in-person issuance of credentials. So good news for PKI because that's exactly where it's needed. Although most of the setups today will actually focus on the lower levels. For example, in the UK with the Verify scheme, today there's no level 4 being offered. It's only level 3 by max. Because level 4 produces so much cost overhead that most of the identity providers are not willing to go into these costs. And I know because I've worked for 2 of the IDPs in the Verify scheme. For example, level 1, strong authentication, are most common social providers. Facebook, LinkedIn, Google, etc. So they have a certain level of assurance, but not pretty high. So this is a challenge for the future of identity, is that for most interesting services, we will need a higher level of assurance. And that will present certain challenges in the industry. So we had authentication, we had Identification. The last step is authorization. And these standards can also be used to do authorization. So when you talk to the service, what am I allowed to do? X5 for now, you can basically encapsulate that kind of information. Again, pretty secure, but maybe not so interesting because authorization is very, very dynamic. Can change on the fly within a second. In the SOAP world, you have something like XACML. Not really got adopted into the market, but it was a good idea. And now we have OAuth and UMA in the REST architectures. OAuth is pretty much used in the industry. Why is it so pretty much used? Because it's very, very agile, developer-friendly. It's built on stateless design, so you can build high-speed deployments on these kind of things. Drawback of OAuth, for example, is you need secure storage. Because if I capture an OAuth token from one of you guys, I can just start using the services like that. There are certain extensions being proposed to OAuth, which you then have proof of possession, for example, but they're not yet there. So most of these standards, like I said, REST architectures, they're pretty good for performance, they're high speed, they're developer friendly, but they lack security. So we had all the different steps, we had all the different technologies, advantages and drawbacks. For authorization, there's one more thing I would like to highlight, which is something that ForgeRock we are focusing on. That's why I want to highlight it here. How to make authorization decisions. So for example, what information do we need to have to make a decision whether somebody, device, or human can do a certain action? These days, everything is centered around attribute-based access control, which encapsulates role-based access control. So it's a pretty interesting concept because it basically all the prior ones it encapsulates. So basically it says a user can have multiple attributes, a device as well. Based on those, you will make a decision whether somebody can access yes or no. Now, some of these attributes will be highly volatile. One of the problems we already have in most national schemes is that addresses change too much for young people. And often a lot of the stuff the national governments are issuing is pretty long-lived. And if the address changes, they already have a lot of problems there. For example, one interesting thing for IoT, which will be very important, is the owner relationship. So when I buy a fridge, I'm the owner of it. The fridge needs to be aware of that, and the services also, because the services will decide what the fridge can do based upon what I basically am configuring into the service. So the owner relationship is very, very crucial for IoT. And of course, things we are starting to think about is, what if I sell a smart device on eBay to somebody else? We need to destroy that relationship and need to rebuild it again for the new user. So these are things that can change quite often. So again, not interesting to encapsulate in long-lived tokens or certificates or etc. This is something can be volatile, can be on the minute. 5 minutes, I've seen it, which is good. I only have a couple more slides. I hope you guys are still with me here. Probably your brains are already induced with caffeine and fresh air. So the question we've all been wondering here is PKI. What can it do in IoT? I've already highlighted on certain aspects where you see the advantages and drawbacks of PKI in IoT. So just to summarize, right? And probably this is up for debate. So the next slide is questions. So when we look at authentication, and the client can be a human or a device, it maybe can be used certificates in, for example, static deployments where you don't need to change too much. Or, for example, in modern IoT applications, for example, a service could be encountered with IoT devices it never seen before. So how are you going to deal with that with PKI? Pretty difficult, because you need these kind of things to respond on the fly. It really can't wait half an hour or an hour, stuff like that. High security setups, as I mentioned, the assurance levels, level 4, for example, requires it. So for these kind of things, high security or static setups, I think PKI is highly suited to be used. The service side, yes, of course, that is the default standard for everything. So I'm not going to contest that. Identification, so basically capturing the identity information inside a certificate. Again, maybe for the client, human and device, for data that doesn't change too much. right? This is exactly the reason why REST architectures and JOT tokens were developed, so they can be issued on the fly, new ones, without really a big hassle. So again, my personal view is that for static data and stateful setups, so again, where the server keeps your session, you build up a session with the server, these kind of things can be interesting. For stateless, it will be a big if. Then the authorization layer, as I said, is highly dynamic. There's certain pieces like the ownership relationship, which maybe change quite often. It's pretty unlikely that we will use PKI for that. Also, to be honest, like SAML is not even suited for this as well. It's only recently with OAuth that we really have large-scale, high-speed deployments for authorization. So, questions? So yeah, this was my talk. Like I said, I'm not a PKI specialist. So I'm very interested to hear what you guys think about it.
Just have one remark to reinforce your statement of the insecurity of MQTT, especially unauthenticated. There was just a talk on DEF CON last year where we were doing a search on Shodan for devices which are doing unauthenticated MQTT. What we found was smart locks of prison doors, US-based prison doors, remote accessible, valves in chemical plants that you could alter. Not sure what they did, but they were valves, and if you switch them on and off remotely from a place in Austria, Hungary, and you don't know what happens. The crazy thing about this, everyone knows Shodan, and everyone maybe knows mass scan, a tool to scan the internet with one tool, the whole internet, the whole IPv6 address space. Sorry, the whole IPv4 address.
Yeah, but that's pretty much.
But actually, you can also send payloads using mass scan. So first you identify every unauthenticated device, whether it's a lock or whether it's that, you structure your payload the way you want it, and then you execute the attack using mass scan to all the devices at the same time. And this is the scale of risk that actually we're talking about.
Pretty scary stuff, yeah. So what I just want to add on that is that indeed these low-level protocols, this is really with the vendors that are interested in that specific space, and yeah, like I said, security is maybe not one of the strong points there. More questions? Come on, no comments. I said some pretty hard stuff for PKI maybe, so if you guys want to defend your business, now is it. Did I say anything that you think, whoa, this is crap, this is just garbage? You can raise your hand, I'm fine with it. No?
I got the question. You look mostly at the consumer angle of IoT because there is this industrial IoT, and Internet of Toys and Internet of Food that you go crazy about, Internet of what?
No.
But is it you're mainly focusing on consumer IoT, or for you when you say IoT is really the umbrella term which also includes M2M or industrial, or in Germany I think it's called Industry 4.0 or something like that. So like you have all these conflicting terms, but they all mean more or less the same thing. What is your...
So in one of the first slides, I showed all the concepts and how they fit together. There you're also at Industry 4.0. But I agree with ForgeRock, we tend to focus on the consumer space because there's a lot of stuff happening today. We have also talked to a lot of industry manufacturing companies, for example. There are other things happening in these industries. They're also developing their own protocols, their own kind of technologies. But I see that they're tending to move towards using, for example, OAuth and these kind of REST architectures with added security on top. For example, I know that proof of position for OAuth tokens is one of the big things with these players at the moment. One more question in the back.
One of the basic concepts which you typically have in PKI and in trust between individuals is non-repudiation. And that's a concept which you didn't touch upon here in Internet of Things. But I think that would be an interesting step to actually go and investigate how much from the logs can be harvested and how secure these logs might be against manipulation. Is it something that standards worked on, or?
That's a pretty good question. I think the non-repudiation ask probably comes from certain segments in the market, which are really keen on having a lot of non-repudiation. I think in the mass scale consumer stuff, often these kind of asks are not high on the list. They just want it to work. They want to have some basic security on it. But I know for even the modern protocols, a lot of extensions being proposed even today as we speak. But I'm not an expert on it, so.
I know certain assurance levels have been defined for Internet of Things. Has there been any certification framework set to actually guarantee that a fridge cannot be manipulated by a non-authorized party if they follow certain recommendations?
That would be a pretty big recommendation, I would say, because it would need to involve a lot of pieces. But that is basically what's happening right now. As I said, there are over 150 standards in the industry right now. And there are a couple big groups already at different levels. You have M2M, you have the higher levels. For example, we as ForgeRock, we're part of AllJoin, which is one of the big consortiums. But again, we're missing the big players, right? No Apple, no Amazon. And these guys are usually dominating the market, so it's a big if.
Mm-hmm. I think even if you do provision, even if you implement provisioning of the device correctly, thank you, where everything is deleted somewhere from the cloud or from that user, if you really look deep into the fridge that you just bought secondhand, I'm pretty sure that there is also some chips that you can reverse engineer and figure out who the previous owner was, what their habits were, because there will probably be cache mechanisms and other type of things which would be reverse engineerable.
True.
So,
I think this is a more broader security topic, right? Yeah. These things I'm talking about today is a piece of the security industry and all the stuff involved. And like I said, secure storage, you also need some secure way of removing all the state on these devices. And yeah, today I don't think a lot of manufacturers have all these capabilities in-house yet. So, no more questions? All right, I'd like to thank you. Thank you very much.